On yesterday's episode, I talked about the Arctic tern, that remarkable bird that flies between the Arctic and the Antarctic and back every single year of its life. Today's episode is about polar things as well, but not in the way you think. So stick around for Life's Potluck Buffet. I'm John Paulus. Thanks for joining me. If you're enjoying Life's Potluck Buffet, please subscribe. If you've already subscribed, thanks so much. I truly appreciate it. If you have a Brave browser, you can now contribute basic attention tokens to Life's Potluck Buffet with John Paulus on YouTube. Thank you for your support, and thank you for listening. Also on today's episode, we're going to ask the cards about how to solve or dissolve life's problems, and we'll see what their advice is. And the reason I say solve or dissolve life's problems is because today's episode is about solvents and surfactants and polar and nonpolar molecules. Well, what's this all about? Well, it's all about cleaning and getting clean, because polar and nonpolar have everything to do with why you can clean something. And what do I mean by that? Well, I'm talking about molecules and their electrical charge. So think of it kind of like, you know how a battery has a plus side and a minus side? You put those batteries in whatever you're putting your batteries in, like AA batteries or AAA batteries. And that is the positive and the negative side. Think of the polar molecule a little bit like that, where there's a positive part and importantly a negative part. And so there are two poles. That's the pole and polar. And the negative part, the reason it's negative is just because it's an atom that likes to attract electrons. And so it's got a high what's called electronegativity. So that's where the minus sign would be. And that is there because there's, say, an atom present that is highly electronegative, or more electronegative than other atoms. And a good example that always gets trotted out is the water molecule. There's two hydrogen atoms and one oxygen atom. And oxygen has a higher electronegativity than hydrogen. So that oxygen atom is where the kind of negative part of the battery would be. And the positive parts are where the two hydrogen atoms are. And so you have what they call a dipole, because they're two poles, like the North and South Pole. So that's what we're talking about when we say a polar molecule. A molecule that has equally distributed electronegativity, that is referred to as a nonpolar molecule. So that just means that there's no, it's not like that battery anymore where you have the plus side and the minus side. There's just kind of like an even charge, let's say. Okay. Now, why does this matter? Well, it matters to cleaning very much, because there's a rule in chemistry that like dissolves like. So that means that polar molecules dissolve polar molecules, and nonpolar molecules dissolve nonpolar molecules for the most part. So that's that rule of thumb. Now, why is that important? Well, because when you're cleaning, the solubility of things is important. In fact, it's the only factor, because what you need is for something to be able to dissolve into something else and then have the something else and the thing you're dissolving be washed away or move away from the article of clothing that you have. So, you have that stain. Let's say it's a grass stain or an oil stain. You need something that's going to dissolve into the oil stain or grass stain, thus creating that solution that can then be removed from the cotton fibers of your shirt. And that's the key to the way cleaning works, because all cleaning is doing is taking something and dissolving it or dissolving into it, however you want to look at it. Doesn't really matter. It's the point is that the cleaning solution is able to dissolve the thing you're trying to clean off of your article of clothing. And so this is where another idea comes in, which is related to the polar and non-polar. And that's things that dissolve in water and things that dissolve in grease. That's probably the easiest way to think about it. And this is the neat thing about soap. The reason that soap works in removing stuff, whether it's bacteria and viruses from your hands, the organic material, or that grass stain on your shirt. The reason that soaps remove this is that they have a part of the soap's composition is polar and part of it is non-polar. And the polar one, which remember dissolves in water, that very same part of it really, really hates to mix with grease, right? Like that old saying, oil and water don't mix. Well, that saying is why soap that you have in a bar or in liquid form, in combination with the water you have that comes out of a sink or any water that you have, you can pour it over your hands, whatever you want to do. That's why that works to remove stains or remove bacteria and viruses from your hands. And it's because there is a dual action here in terms of solving and dissolving in the substances. So the part that likes to dissolve in water really, really hates oil, and so it won't dissolve in oil, which is great because the part of the soap's chemical composition that loves to dissolve in oil and grease and organic compounds basically dissolves into those, and the water won't dissolve into them. And what it ends up forming is a kind of M&M, those candy with the hard outer shell and the chocolate inside, the sugar shell. Think about the sugar shell of the M&M as being the water part, the part that dissolves in water, and then think of the inside as the stuff that does not dissolve in water, which I guess actually in a certain way that's kind of true. And then realize that what that means is that the water that you're running over your hands or the water that you're running through your shirt is going to take with it that M&M, which has trapped the organic substances on the inside of it, like the grass stain or the oil stain or the whatever, bacteria or virus. It has trapped those in this shell of basically water soluble stuff. And so the water will take it away with it. But what if you don't want water to touch something because the water might have different effects on different parts of the material or different materials that something you're cleaning is made of. Well, what do you do then? Well, that's where dry cleaning comes in. And dry cleaning, it just simply means cleaning without water. There's a liquid solution that, dry cleaning doesn't mean that there's no liquid. It means that there's no water. And this is where, again, polar and nonpolar come into play. Dry cleaning solutions are nonpolar because that's the whole point of dry cleaning, is that you're not using water, because water will damage or otherwise distort the fabric that you're cleaning. And there might be water soluble things in the thing you're cleaning that you don't want to run water over as well. So that's why you need to have a non-polar solution that can dissolve the organic stains and the hydrocarbon stains, the oil and grease and so forth, but it can't rely on water to dissolve the part that then goes down the drain with in the water as a solution, the water soluble part, because it needs to just use the nonpolar liquid to dissolve the stains and also to be carried away. And another element that's important is that it needs to be able to turn into a vapor so it doesn't stick around on your clothing. That is an important part of the process, and that is why dry cleaning solutions are what are called volatile. And that means that they, it's very easy for them to become a gas. But there's one thing that it's best if dry cleaning solutions are not, and that's flammable, because volatility and flammability are two different things. And the most common dry cleaning solution that is used today is called tetrachloroethylene. It's also called perchloroethylene, or PERC in the dry cleaning business. And PERC is a liquid that has a very detectable odor. That's when you're smelling dry cleaning, you say, "Oh, this smells like it's been dry cleaned." When it comes back for the dry cleaner, that is the odor of the PERC, the tetrachloroethylene, that hasn't fully been removed from your dry cleaning. So that's what you're smelling when you smell that. Now, the wonderful thing about the tetrachloroethylene is that it is inflammable. It does not go on fire. It cannot catch fire. It also is non-explosive, so it can't blow up anything. So those two things together make it an ideal solvent for dry cleaning. Because you see, before a person named Sylvia Stoesser, who was a PhD chemist who worked for the Dow Chemical Company in the 1930s. And Stoesser did a lot of groundbreaking work working at Dow Chemicals. And one of the things that she was studying and came up with a solution to was the solution for dry cleaning solution. Because earlier in laundering, a common nonpolar compound in the soap, both for wet cleaning and dry cleaning of laundry, was naphtha. And in terms of soap making and in the cleaning industry before Sylvia Stoesser's time, naphtha was used as this solvent that was not water soluble. It was the non-polar solvent part of the soap for laundering. And it was highly flammable. And in fact, you probably have seen or smelled or uh, maybe even worked with naphtha before, because if you've ever cleaned your paint brushes when you're painting with, say, an oil-based paint or a similar base of paint, the way that you clean those brushes, and again, this is because of the solvent, the oil solvent that naphtha is. Perhaps you're familiar with mineral spirits. That's what in the U.S. and Canada they're called. If you're in the United Kingdom or other English-speaking countries, you may call it white spirit. Well, that's what the naphtha part of the cleaning solution was. And that is highly flammable, highly, highly flammable. And that is a problem because we don't want things catching fire because that's dangerous. And that's where Dr. Sylvia Stoesser saved the day, because she developed a cleaning solution that used perchloroethylene, which is the perc that is in the majority of dry cleaning solutions that are in use today. So let's draw a card in honor of Sylvia Stoesser and the solutions she came up with about solutions. Yellow lemons, blue dumplings, magenta noodles. Cards, tell us somethings. It's card 19. It's only desperation if you have no actual strategy. Always act in line with an empowered plan that advances your progress towards your goals. The exact same action can often be viewed as either desperate or strategic, depending on whether it is part of a plan or not. Think about a decision you're making right now. What would be the desperate thing to do? What would be the empowered thing to do? I think that's a really good card to honor Sylvia Stoesser, because when the world was in a desperate situation about cleaning solutions, she did the empowered thing and came up with the solution. I'll see you tomorrow on Life's Potluck Buffet.